Find the exact value of the sine of pi over 5. Find the value, the exact value, of the sine of pi over 5. Now this value for sine you may not be familiar with, an exact value. And to get to its exact value, we'll have to employ a couple of trigonometric identities. So first we begin with the fact that we want sine of theta to be equal to the sine of pi over 5, so that theta is equal to pi over 5. That'll allow us to rewrite this as 5 theta equals pi, or 3 theta plus 2 theta equals pi, or 3 theta equals pi minus 2 theta. We can then conclude that the sine of 3 theta is equal to the sine of pi minus 2 theta. One identity here is that the sine of an angle is equal to the sine of pi minus that angle. So that will allow us to write that sine of 3 theta is equal to the sine of 2 theta. Next, we're going to substitute in two trigonometric identities. One, a triple angle formula for sine, and a double angle formula for sine. On the left, we have 3 sine theta minus 4 sine cubed theta, and on the right, 2 cosine theta sine theta. Now, because sine of theta is not equal to 0, because theta is equal to pi over 5, we are free to divide by the sine of theta in this equation, thus simplifying the equation for us. So that'll give us 3 minus 4 sine squared theta equals 2 cosine theta. Next, we're going to employ another trigonometric substitution, a Pythagorean trigonometric substitution, and for sine squared we're going to replace it with 1 minus cosine squared. Then, doing a little distribution and rearranging of terms, we will find that this equation, 4 cosine squared theta minus 2 cosine theta minus 1 equals 0, is in the form of a quadratic equation. Quadratic equations can be solved using the quadratic formula. So we can write that cosine theta is equal to 2 plus or minus the square root of 20, all divided by 8. This can be further simplified by reducing the radical to 2 radical 5. And then dividing everything out by 2, we can simplify this even further and write that the cosine of theta is equal to 1 plus or minus the square root of 5 all over 4. Next, we make an observation that the angle theta is in quadrant 1. Therefore, the cosine of theta will have to be positive. Thus, we can say that the cosine of theta is the positive root of this 1 plus the square root of 5 all over 4. Now in a moment, we're going to need cosine squared, so we're going to have to square 1 plus radical 5 over 4. Carefully squaring the binomial on top, we get 1 plus 2 radical 5 plus 5, and squaring the bottom we get 16. And cleaning that up we get 6 plus 2 radical 5 all over 16. That's cosine squared. Now, what we're really after is what is the sine of theta, because the sine of theta represents the sine of pi over 5. And using another Pythagorean identity here, we can write sine as the square root of 1 minus cosine squared. So now taking what we found for cosine squared and substituting it into this formula, we have the square root of 1 minus 6 plus 2 rad 5 over 16. And with a little bit of algebra and simplification here, we can write that the sine of pi over 5 can be expressed as the square root of 10 minus 2 radical 5 all over 4. and that is the exact value which we confirm with Desmos. Pretty cool. I hope you enjoyed this video. Please like, subscribe, and hit that notification bell for more videos. Stay tuned.